Okay, so welcome to day one of trying to solve LeetCode problems and try to get hired by FANG company. Let's start with 1038, binary search tree to greater sum tree. Okay, so given the root of a binary search tree BSC converted to a greater tree such that every key of the original BST is changed to the original key plus the sum of all keys greater than the original key in BST. So example one, given this binary search tree, we should just, okay, so all the keys greater than 4 are going to be to the right. All the keys greater than 6 are going to be to the right. All the keys greater than 5 are going to be to right. So we should probably just iterate from right to left, right? Because the lowest element is going to be at our rightmost, and the greatest element is going to be at our leftmost node. Because everything up and to the right is going to have to be added to that node sum, right? I'm just thinking here that we should go to the right. Like once we reach a node, we would do like sum, which in this point would be 0 plus the node's value. Then we would go back, we would go to the left, we go this plus the node's value, and that would basically be it. So this is definitely a DFS type algorithm in which we have a node, and we would also have the current sum, which we can just name it key sum, right? And here, if node is none, we simply return, right? And else, we're going to go to the right. So we're going to do DFS node dot right key sum. And actually, I mean key sum, it probably would be better to not have it as a value, but just a global variable from our function, right? So key sum equals 0 because we're going to be changing it constantly. So once we go to right, here we are going to do key self.key sum plus equal to node that val, and yeah, then we go to the left, and that would basically be it for algorithm. Let's just see if this works. 36 is not a valid value for the expected return type tree node because we're not supposed to return the sum. We're supposed to return a whole tree. What we could do is actually just return here root. What we could do is node.val equals to self.key sum. And once we have this, we're going to keep saving the sum, and the value is just going to be equal to that current value. So accepted runtime, and that was it for our algorithm. Let me just be sure. So given the root converted to a greater tree, so yeah, we're not supposed to create a brand new tree. Just by doing this should be more than enough, and our accepted solution beats over 44%, which really makes it very efficient. It could probably even be a little bit more, but I'm satisfied with the solution.